Before we jump into the main topic for today, we want to either introduce or remind you of some information related to polygons. So first of all, what is a polygon? A polygon is a plane figure with at least 3 straight sides and angles. A plane figure means that it is two-dimensional, because a plane is a two-dimensional surface, so this figure needs to fit in that two-dimensional space. And it needs to have at least 3 straight sides, because if we have fewer than 3 sides, we can't actually enclose an area and create a shape. We need that third side in order to create a full shape. We like to name polygons depending on how many sides they have. So 3-sided polygons are called triangles. 4-sided polygons are called quadrilaterals. And you may be more familiar with some specific quadrilaterals like squares or rectangles. 5-sided polygons we call pentagons, and 6-sided polygons we call hexagons. Now, there are names for polygons which have more than 6 sides, but these are probably the most common and probably the ones we'll be working with the most this week. There are also special polygons which we call regular polygons. So regular polygons are polygons, but where the sides are the same length and the angles are all the same measure. You are probably familiar with some regular polygons, but under different names. So for example, a regular triangle is an equilateral triangle, a triangle where all of the sides are equal and all of the angles are equal. A regular quadrilateral is a square, because that's a quadrilateral where all sides are the same length and all of the angles are the same length, 90 degrees. Here would be an example of a regular pentagon. All 5 sides are the same length and all of the angles are the same measure. And here would be an example of an irregular pentagon, just to give you an idea. So let's have a closer look at triangles, which remember are 3-sided polygons, like these. So let's ask ourselves, what do the angles of these triangles add up to? If we were to call one angle A, another B, and another C, do those add up to a specific value? Spoiler alert, they do. And you may already know what they add up to, but let's go ahead and see if we can figure it out together. Let's take a triangle, and let's think of it as being on the ground. We're going to take a walk around this triangle. So in doing so, we're going to have to make 3 turns in order to end up back where we started. So let's call those turns A, B, and C. Now, by going around this triangle, we ended up back where we started, which means that we essentially just walked in a circle. And a circle is 360 degrees. So that means that those turns that we took, A, B, and C, must also be a total of 360 degrees. But notice that those are what are called the exterior angles of the triangle. They're not the angles that are inside the triangle. So we're going to call the angles inside the triangle little a, b, and c. Now notice that big A and little a together make a straight line. So that means that big A and little a together must be 180 degrees. And so if we subtract little a from both sides, we can actually find a way of writing big A using little a. And we can do the same thing with the B's and the C's. So now we can use that information in this equation where we know that big A, B, and C are 360 degrees. We can replace those with how we know they relate to the little a, b, and c. We start combining some like terms and get a, b, and c on one side of this equation all by itself, we'll see that little a, little b, and little c add up to 180 degrees. So all of the angles in a triangle are going to add up to 180 degrees. Feel free to pause the video here and work through the algebra yourself, as we went through the algebra kind of quickly. Another way you can convince yourself that the angles of a triangle add up to 180 is to cut out 3 copies of the same triangle and label their angles A, B, and C. Then rearrange those 3 triangles so that the angles A, B, and C are all fitting together, kind of like this. And you'll notice that when you arrange the triangles this way, no matter what triangle you cut out, they will always be able to form a straight line. And a straight line is 180 degrees, which also tells us that A, B, and C add up to 180 degrees. So now let's see if we can figure out what the angles of a quadrilateral add up to, like this one. Now this won't be as involved as as it was for the triangle, because we can actually now use what we know about a triangle's angles to help us answer this question. Because we can cut a quadrilateral down the diagonal, and that'll actually cut it up into two different triangles. So we know that the orange triangle's angles are going to be 180, and so are the pink triangle's angles. And the quadrilateral is really just the orange triangle and the pink triangle's angles added together. So that means that the quadrilateral's angles are going to add to 360 degrees. Since we can do this with any quadrilateral, that means that the angles of any quadrilateral are going to add up to 360 degrees. So your first task of the day is to figure out what the angles of a pentagon and a hexagon are all going to add up to. And feel free to use what we just learned about triangles and quadrilaterals to help you figure this out. See if you notice any patterns in what all of these angles are adding up to, and see if you can describe how that pattern would continue.